Let's look at determining if a vector field is source-free using the divergence test. The definition of a source-free vector field is a field that has a stream function, meaning that there are no sources or sinks. With no sources, there can be no flow out, and since flux is a measure of flow out, there can be no flux. The same is true for sinks and flow in. Knowing that the divergence of a source-free vector field is zero allows us to test if a field is source-free or not, although the field has to conform to certain conditions so that the theorems apply. The first theorem states that the divergence of a source-free vector field is zero if the field is continuous and has differentiable component functions. This is proved by taking the divergence of f when the components are substituted by the components of G, which can be done because f is source-free. The second theorem states that the divergence of f is zero if and only if f is source-free, which holds true as long as f is a continuous vector field, is simply connected, and has a differentiable component function. This is proved by taking the converse of Theorem 1 over a simply connected domain, although the full proof is too technical to include here. Now let us try an example of applying the divergence test. To determine if the field f of xy equals 3x squared y squared minus 3y, 6 minus 2xy cubed, is source-free, we must check if its divergence is equal to 0. The function must also conform to the conditions of the theorems, specifically that the domain is simply connected and the field is continuous and has differentiable components. Note that the domain of f is R2, which is simply connected. Furthermore, f is continuous with differentiable component functions. Therefore, the function conforms to all of the conditions, and we can use the divergence test for source-free vector fields to analyze f. To find the divergence of f, we must take the derivative of the x component with respect to x, and the derivative of the y component with respect to y. This gives us 6xy squared minus 6xy squared, which is equal to 0. Since the divergence is equal to 0, the field f must be source-free by the divergence test for source-free vector fields.